This is the last question from the chapter 21, logarithm. We have already completed till question number 12 in our previous video. So today we'll start from question number 1 of 13. Okay, so let's solve question number 1. Let us calculate the value of log to the base 4, log to the base 4, log 256 to the base 4. So we are asked to calculate the value of this expression, isn't it? Log to the base 4, log to the base 4, log 256 to the base 4. Now let us find the factors of 256 in terms of 4. Okay, 256, we can write this as 4 6 is 24, 1 in hand, this becomes 16, 4 4 is 16, 4 1 is 4, 5 6, 2 in hand, 4 6 is 24, 4 4 is 16. So 1 2 3 4, this means 4 to the power 4. 4 to the power 4 is 256, isn't it? Log to the base 4, log to the base 4, log, instead of 256 I am writing 4 to the power 4. 4 to the power 4 is 256, okay, to the base 4. This equals to log to the base 4, log to the base 4. This 4 we can write before log, isn't it? If we have log a to the power m, then we can write this as m log a, isn't it? This power m comes before log. So this 4 we write before log, this power 4 we write before log, 4 log 4 to the base 4. So log 4 to the base 4 is 1, isn't it? Because log a to the base a is 1. Log x to the base x is 1, isn't it? This will give us log to the base 4, log to the base 4, and this 4 we have here into log 4 to the base 4 is 1. So log 4 to the base 4 into 1 is log 4 to the base 4 again, isn't it? Equal to log to the base 4. Now log 4 to the base 4 is again 1 into 1. 1 into 1 is 1, so we don't write 1, okay? This is 1. Log 4 to the base 4 is 1. So 1 into 1 is 1. Log to the base 4, 1, okay? Log 1 to the base 4. Now we have log 1 to the base 4. Log 1 to any base equal to 0, isn't it? The value of log 1 is always 0, okay? So this gives us 0. So this is the solution for question number 1 of 13, okay? Question number 2 of 13. Let us calculate the value of log a to the power n upon b to the power n plus log b to the power n upon c to the power n plus log c to the power n upon a to the power n. So we are asked to calculate the simplest value of this expression. Let us find, okay? So we have log a to the power n upon b to the power n plus log b to the power n upon c to the power n plus log c to the power n upon a to the power n. So if we have log m upon n, we can write this as log m minus log n, isn't it? Log m upon n is log m minus log n. So we will write this as log a to the power n minus log b to the power n. This plus we write here log b to the power n minus log c to the power n plus, this plus we write here log c to the power n minus log a to the power n, isn't it? So we have here plus log a to the power n and minus log a to the power n. Same number, opposite sign, isn't it? One is negative and the other is positive. So we can cancel this. Similarly, minus log b to the power n plus log b to the power n. Same number, opposite sign. So we can cancel this also. Log c to the power n is negative. Log c to the power n is positive. So this also gets cancelled. ultimately we have 0 left, isn't it? So this is the solution for question number 2 of 13. Question number 3 of 13. Let us show that a to the power log x to the base a equal to x. So we are asked to prove this relation, isn't it? To prove this relation, what do? We suppose log x to the base a equal to m. Okay, let us suppose log x to the base a equal to m. See, we are just supposing this. Now this is a logarithmic equation. Now let us convert this logarithmic equation to exponential equation. Okay, so how do we write this? This a base we write here. This m comes here as power equal to this x, isn't it? This x goes to the right hand side, or a to the power m, isn't it? What is m? M is log x to the base a. So we can write log x to the base a instead of m, because m is log x to the base a. This will give us x. So hence proved, isn't it? A to the power log x to the base a equal to x. This is what we are asked to prove. Hence proved. Question number 4 of 13. If log 2 to the base e times log 25 to the base x equal to log 16 to the base 10 times log 10 to the base e, then let us calculate the value of x. So this is the given equation. We are asked to find the value of x. Okay, let us rewrite the given equation again. Log 2 to the base e times log 25 to the base x equal to log 16 to the base 10 times log 10 to the base e. Okay, now we keep this log 25 to the base x in the left hand side, log 25 to the base x. We bring this log 16 to the base 10 to the right hand side by cross multiplication. Okay, because we have multiplication sign here, means this will come to the denominator. Okay, log 16 to the base 10 equal to, we have log 10 to the base e in the right hand side. Now we take this number log 2 to the base e to the right hand side. Here also we have multiplication sign, so this number goes to the denominator by cross multiplication. Log 2 to the base e, or this 25 we write as log 5 square. Okay, 25 means 5 square, base is x, we write x base. Log 16 to the base 10, 16 we can write as log 2 to the power 4 and the base is 10. 16 is written as 2 to the power 4. 2 to the power 4 is 16 equal to, here we have log 10 to the base e upon log 2 to the base e. Bases are same. This means we can write this as log 10 to the base 2. If the bases are same, then we write log 10 to the base 2. Okay, this 2 power 2 we write before log. Okay, because we know that log a to the power n is n log a, isn't it? So we write this as 2 log 5 to the base x upon 4 log 2 to the base 10. This 4 is brought before log. 4 log 2 to the base 10. 2 1 is 2, 2 2 is 4. Here we have log 10 to the base 2. Now let me continue here. So we have log 5 to the base x. 1 into log 5 to the base x is log 5 to the base x. In the right hand side we have log 10 to the base 2. First we take this 2 to the right hand side. Okay, so this 2 comes here, 2 into log 10 to the base 2, log 10 to the base 2, and this number log 2 to the base 10 will also goes to the right hand side into log 2 to the base 10. Log 2 to the base 10 goes to the right hand side, or log 5 to the base x equal to 2 into, this is 1. Okay, why? Because we can write this as log 10 to the base 2 into 1 upon, if I take this number to the denominator, this 10 becomes log log 10 to the base 2. Okay, log 2 to the base 10, if I take this number to the denominator, this becomes log 10 to the base 2. Now we have log 10 to the base 2 and log 10 to the base 2. One is in the numerator and the other is in the denominator. So we can cancel this. We have log 5 to the base x equal to 2 1 ja 2. This is a logarithmic equation, isn't it? So we can convert this to exponential equation. Or this x we write here, this 2 comes here as power equal to 5. This 5 we write here. X equal to, when we take this square to the right hand side, becomes root under 5. Okay, so the value of x is root under 5. This is the solution for question number 4 of 13. So we have completed all the questions from this chapter. I hope you understood this. Stay tuned for more videos. Thank you.